So hello, today we are going to start one interesting RC circuit. We will see the response, time domain response or transient response for a applied input step voltage. So let's draw the circuit first. So suppose, so just 1 second. Okay, so suppose this is the just 1 second. So okay, so now suppose this is the circuit. So this is R, here also one resistance is there, R. So suppose this is R and this is R and this is suppose C. Okay, so what, and if we give, and we will take the output across this capacitor, parallel RC capacitor, and suppose this is 0, this is 5 volt step input. Okay, so now we'll realize the, so now see, at the initially at t equal to 0, the capacitor act as a short circuit. Why? Because at t equal to 0, means high frequency. So at the very high frequency, capacitor act almost short circuit. Or we can say initially capacitor is uncharged, means 0 volt. Or we know that capacitor voltage cannot change instantaneously or suddenly until we not give the infinite current. So since capacitor voltage cannot change instantaneously, so whenever we apply the step input, the output will be, so suppose this is output, so this is actually input 0 to 5 volt. So what will be the output voltage, capacitor voltage initially? This is 0, so this is 0 volt. Now at the time elapses or time go ahead, now so initially capacitor is 0. Why? Because capacitor is short circuit. Now just 1 second. So why capacitor initially 0? So t equal to 0, capacitor is short circuit. So if you see, if you draw the equivalent circuit, so this is the equivalent circuit. Now this is R, this is step, this is R. So capacitor is short. Now if capacitor is short, what is the total equivalent output impedance? Since R is also parallel to this short, so this total will be short. Total equivalent resistance is short. So that's why this V out is equal to 0. Now when time elapses, now, and one more thing, that time capacity is 0. So what will be this current? If you see, what will be this current? Now this current will be, this is 5 volt, so this is 5 by R. So what will happen? This is the IR current. If you see this IR current, this current is 5 by R. Okay, now what will happen next? Now next, capacitor is going to charge. Okay, so current will flow through, all the current will flow now through the capacitor, because capacitor R is short, capacitor is short, so all the no current goes through this arch, because the voltage across this parallel resistance is 0. So that through parallel resistor no current will flow. So current will go through the capacitor, and capacitor going to keep on charging. If capacitor going to charging, so capacitor voltage increase like that. Just not state, so it will be increased like that. Now when capacitor output capacitor voltage increase, so this IR current will be dropped, because this is 5, initially it is 5 minus 0 by R. Now this is some voltage drop across the capacitor, so this voltage difference, this resistor is reduced, so current will reduce. Now current will be reduced. Now what will be the value at steady state? Now at steady state, what will happen? Now steady state, we know at the steady state capacitor is open circuit. So at steady state capacitor is just open circuit. Now we know this is V out, this is your step. Suppose this is both the same resistance R value. Now what will be the final steady state output voltage? So since this 5 volt is divided between these two resistors, so what will be the according to voltage divider rule, this V out will be, so V out will be 5 by 2, that is 2.5 volt. That means capacitor voltage will be settled down at 2.5 volt. Okay, and what will be the steady state current now finally? Now see, when the steady state capacitor open, no current will further flow the capacitor, all the current will flow to the this resistor like that. That means 5 by 2R, or this the initial is 5 by R. Now 5 by 2R means 2.5 by R. So this steady state current is 2.5 by R. That is the current. Now this thing, if you want to analyze more intuitively, what happened actually, let's see. Just see. Whenever capacitor is short, no current flow through this resistor, this parallel resistor, all the current flow through the capacitor, and the capacitor voltage increases. Now initially what will happen? So that's why when this is the short circuit capacitor is short circuit, what was the current I told? That is 5 by R. Now just 1 second. Now what happened? Just see, just wait. So next what will happen? If you more intuitively, if you want to see, suppose this one like that. So this was the circuit actually. Now initially I told the capacitor voltage was 0. So this, the output parallel resistor, the voltage across parallel resistors is 0. So no resistor will flow. Then what happened was all the current will flow. See, this is also 0 actually, both are 0. So if you see, all the current flow like that through this capacitor, and that is the 5 by R. Okay, next, when capacitor keep on little bit going to charge, capacitor voltage increase. If capacitor voltage increase, this parallel resistors, whatever the parallel resistors, that means voltage across this parallel resistors increase. Now since capacitor voltage increase, this is 5 volt, this current is reduced, this current, whatever is this current going to reduce, and little bit, that's why this is reduced, and the current is now flow through the capacitor as well as the parallel resistor, both. Okay, now when capacitor voltage is going to 2.5 volt, when capacitor voltage is suppose 5 volt, when it is reach this 2.5, now see, this series resistor current is 2.5 by R, and this parallel resistor current 2.5 by R. That means at the steady state what will happen? Let's see. At the steady state what will happen? Just wait 1 minute. 1 second. So what happened at the steady state? Actually, so this capacitor voltage is 2.5 volt. This is R, this is R, this is 5 volt. Now when capacitor goes to 2.5 volt, then this current also 2.5 by R, and this current also 2.5 by R. That means 2.5 by R actually, this current also means same current will flow like that. No more current flow through the capacitor. That means whenever capacitor voltage goes to 2.5 volt, so this is 2.5 volt. That means whatever current flow through this series resistance, same current will flow. That means same current will flow through both the resistor, and further no more current flow with the capacitor. That's why capacitor voltage is locked at 2.5 volt at a steady state, and that current, the 2.5 by also steady state current also settle at 2.5 by at the steady state, because further no more current flow through the capacitor. So this is the behavior. I hope you will understand this circuit behavior. Okay, thank you.